Chapter 8, Control Systems, Part 2 of 2. Processors and Controllers. Processors and controllers are responsible for telling a control system what to do. A processor is a part of a computer that manipulates data and performs calculations. The data is provided by the input device. The controller is the input of a control system that provides directions to output devices in order to control the operation of the system. Microprocessors. A microprocessor is usually a single-chip computer element that contains a control unit, central processing circuitry, and all the necessary logic functions to serve as a central processing unit of a microcomputer or as a dedicated automatic control system. Microprocessors are capable of performing mathematical and logical operations. A microprocessor is responsible for three tasks: performing math functions, shifting data from one memory location to another, and making decisions and skipping to a new set of commands based on some predefined condition. The microprocessor's ability to process data is measured in bits. The microprocessor's speed is measured in hertz or cycles per second. If a microprocessor is capable of doing 1 billion operations in 1 second, then the speed is measured in gigahertz. Microcontrollers. A microprocessor must be connected to a series of integrated circuits that provide inputs and outputs. A microcontroller consists of a microprocessor, memory unit, input and output ports, a crystal oscillator for timing, ADCs and DACs all on one circuit board. The microcontroller is intended for small, dedicated applications such as automobile engine control systems, remote controls, power tools, and toys. These types of applications fall under the category of embedded controllers because the controller is physically embedded in the device. The BASIC stamp is a microcontroller that is programmed using the Parallax P-Basic programming language. The program is stored in electrically erasable programmable read-only memory or rewritable memory chip that does not need power to keep its content. The P-Basic programming language allows you to control input and output devices, including turning auxiliary devices on and off. Computer-based controllers. The computer-based controllers uses one of the computer's expansion slots to house an interface card. Those expansion slots are directly connected to the motherboard. The interface card has several input and output locations that are used to bridge the gap between the computer and other components of a control system. Computer-based controllers became feasible with the availability of low-cost computers. Their software systems are graphics-based, which gives the operator the ability to program using an icon-based system and monitor the process graphically. These graphics displays are known as human-machine interfaces, or HMIs. Programmable logic controllers. Programmable logic controllers, or PLCs, are standalone systems that can be programmed to accomplish a variety of tasks. The controller itself contains several input and output ports that can be customized and monitored by the logic controller circuitry. The controller will constantly check the status of numerous sensor inputs that will direct output actuators such as motors, solenoids, lights, displays, and valves. PLCs have advantages over other types of controllers. Programming. Whether it's a basic stamp, a PLC, or a microcontroller, all controllers need to be programmed. Two common approaches to programming controllers are graphical flowcharting and ladder logic. Text-based programming methods such as P-Basic are still used, but such methods are being replaced with more user-friendly icon-based software programming systems. Graphical flowcharting. Icon-based softwares use graphical flowcharting symbols in place of text-based code. Ladder logic. The ladder logic diagram is the most common language used in a program a PLC. The programming style is similar to the way in which relay diagrams were drawn by electricians at the time of its introduction. Examples of control systems, process control systems. In the manufacturing environment, a process control system is a specific type of closed-loop system that monitors an industrial process so that a uniform product will be produced. This is done by monitoring inputs from the system and then making the appropriate changes in that system to keep things within the control limits. Servo mechanisms. A servo mechanism is a feedback system that consists of a sensing element, amplifier, and a servo motor. Numerical control. Numerical control refers to the automation of machine tools that are controlled by encoded commands. In your engineering notebook, please answer the following questions. What are some examples of digital input devices? What are the characteristics of microcontrollers, computer-based controllers, and programmable logic controllers? How is the heating and cooling in your house a control system? How are process control systems used in industry? Identify 3 examples of control systems that you would interact with in your everyday world. What function can lights and buzzers serve in control systems?